Hi, this is Thomas from Apex Game Tools. In this second video on height navigation, we'll be looking at the changes made to height navigation in version 2.1 of Apex Path. We will start by looking at what you need to do to upgrade from previous versions, and then we'll be looking at the changes made, components added, and the configuration options. In another video, we'll be looking at how you can extend this new functionality with your own components. So let's start by looking at how you upgrade from previous versions to 2.1. If you've already upgraded previously from a previous version to 2.0, you already know of the tool in the toolbar under Apex, and we have Upgrade Scene. And this is exactly the same thing that you will use now. You simply click Upgrade Scene. If you have Apex Steer installed, you will also get this prompt. You can simply say no to that if you haven't already upgraded. If you have already upgraded to Apex Steer, there are no Apex Steer changes. It is solely Apex Path. So I'll just go ahead and say no to that. And that's it. You will need to do this for all the scenes you have in your project to upgrade your units. Now, I should mention that the upgrade isn't exactly necessary. If you do not use height navigation at this point, you will not be required to update your scenes, as it's only units that are actually using height navigation that are affected by these changes. So let's have a look at what we've changed. Now let's start by the simplest change. On the game world, if you've seen the previous video on height navigation, you are aware that we have this navigation settings component where you can select different settings for height navigation. We now have only three options: no height sampling, height map, or raycasting. Previously there was a fourth option, sphere cast. This has been removed, so if you had that selected previously, you will now have raycast selected by default. Now this hasn't changed in any way other than we have removed one of the options. This component does, however, affect the other changes. So the value that you select under height sampling will affect available options on other components, as we will see in just a bit. So the main change is done to the units. Previously, height navigation was carried out by the steerable unit component itself. That is the component that actually does the steering. Given input from steering components, this will actually do the required steering. This component is now even simpler than it was before. As you can see, we have removed some of the properties having to do with height navigation, because height navigation is no longer controlled by this component. Instead, we have a new component called a height navigator. In this case, the default height navigator, which is the component that is included with the product by default. So unless you override this, this will be what you will be using. And as you can see, this new component has these three properties that we previously had in the steerable unit component. So it defines the gravity, the ground stickiness factor, and terminal velocity. So these have simply moved, they have not changed. Now, before we go into the next part of this component, let me just explain the reasoning behind doing these changes. Now, there are two main reasons. The first reason is that having this as a separate component allows you to override the default behavior and provide your own, and it also provides additional options for various modes of height sampling. The second option, or second reason, is that if you do not require height navigation at all, you can simply avoid it altogether. So that means that instead of where previously the steerable unit component would basically do height navigation whether you needed it or not, in cases where you didn't actually have any height sampling, it would still sample heights, it would just simply sample the same value over and over. So obviously, while not a huge performance hit, it would still be unnecessary time used because you wouldn't be needing it. So now you can avoid it altogether if you wish, and if you do use height navigation, you now have a wide set of additional options. Now, as you may have noticed in the changelog on 2.0, we had a listing of known issues, and one of these issues was that units would actually not follow the terrain properly when they were moving across heights. So moving up ledges, for instance, units would actually float somewhat above the ground, and that is part of what has been fixed in this update. We still do have a few pending issues, but I will get back to that in the end. So let's get back to this default height navigator and look at the different options. So there is actually just one option left, and that is the height sampler. The height sampler controls how the unit actually samples its height, how it determines what height it is supposed to be at on the next frame. This list is dynamic, and it depends on two things. It depends on the type of collider on the unit, and then it depends on the setting that we just saw before on the height navigation, on the navigation settings component, the height sampling mode. So in this case we have height map sampling, which means that in this list we will also have some height map related components. Now this height map sampling actually provides the longest list of options. Raycasting is also an option here if you wish. Normally you would obviously use height map when you actually are generating a height map, but you can use raycasting for more precision if you wish. So let's just quickly go through the different types, and I'll just do a quick comment on them. This comment will also be listed down here underneath. We will have a small note that says what this height sampler actually does. So the first one, height map, well, obviously it uses the height map. It samples 3 points. It samples the back, the middle, and the front of the unit. Not to the sides, but just in the back and the middle and the front of the unit. So this basically assumes that the unit, when moving across stuff, it will actually hit stuff with its front. If it's a very big unit with a large radius, this will not be an optional optimal option, because it would be able to hit terrain at points on its body that would not be the front, basically. So in short, this is a very fast provider, but it's not super accurate. Height maps in general are not very accurate because they have this granularity that you set yourself, and the accuracy is dependent on that. Next up we have the raycast 3-point. It is similar to the first one we just covered. It just uses raycasting instead of the height map. So it is more precise. It is also a bit more costly. On average it's probably twice as costly as the height map, but it does provide more accuracy, and also obviously if you just use raycasting for sampling, you can avoid height maps altogether, which will save you a lot of memory. Next we have sphere casting. In this case this is available because our unit has a sphere collider. Obviously if it was a box, this would not be an option. Vertical capsule colliders and spheres will have this option. Now sphere casting is super accurate. It does not suffer from the other limitations I mentioned with big units. It doesn't matter how big it is, how wide it is, this will be super accurate and it will follow the terrain no matter what. It does, however, cost quite a bit more in terms of performance. So while the raycasting was about twice as costly as height map, this is about 8 times as costly as the height map and 4 times as costly as the simple raycasting. So if you have loads of units, this probably will be a little too costly, but you will have to test that out yourself. It is the most precise option you can get. And then we have two additional ones at the end here. This will be available no matter the collider and no matter the height navigation settings. Gravity only basically means that there will be no height sampling, so it will only support gravity. So this is only really viable if you have a scene that is actually flat, but units can sometimes be mid-air and you want them to fall to the ground. Then you can use that option. And finally, you can use custom option, which will allow you to provide your own height sampler for use with this default height navigator. But this is a topic that we will get back to in the second video. Now, as mentioned, this setting or this list, the available height samplers are dependent on the collider and the navigation settings. So if for whatever reason you would want to change the collider on your unit, then you will need to ensure that you actually pick an appropriate sampler after you change the collider. The same goes for the height navigation settings. So let's say, for instance, we have selected height map 3-point for this unit, and then I go to my game world and I change my height map to raycasting instead. Now obviously now height maps are not an option, so on my unit it will also no longer be an option, and it will already have picked the first option on the available list, in this case raycast 3-point. So it will automatically do this for you, but if you want something else, you might need to revisit your units to ensure that you actually pick the height sampler you want. Obviously it will only change it if it is not compatible with the new setting. So if you had it set up to spherecast, it would obviously not change it. So that's about it. One final thing to mention is that if you do not require height navigation at all, that means you don't care for height navigation, you don't care for gravity, you can simply remove this component altogether. In that case, you can avoid the overhead that is involved in this, and the steerable unit component will basically just call a void method that does not take any time. So with that, that's all for now. So see you in the next video.